Hi guys, I'm just going to explain a little bit about expectation and variance, two of the key concepts in probability calculus. So what is expectation? Expectation is like the true value you'd expect to get. If you had a very large sample of data and took the average, you'd get a very precise estimate, and hopefully that would then converge to this thing called the expectation. It's the true value, and it comes from, it's a theoretical concept based on the known distribution. So it's not based on the data expectation, it's based on knowing the distribution function. So it's a model concept, if you like. If I've given you the probability distribution from a model, you can then tell me what the expectation is. So expectation. What does that mean? So it's sort of an operator. We can write it as E for expectation. And so we can say E, and let's take any function, if you like, of a random variable. So G of some random variable Y. So how do we calculate? If I give me some function of a random variable, it could be the square of Y, it could just be Y, it could be any function you like. How do I work out the expectation? Well, it turns out, let's do it for the discrete random variable first of all. It is simply, it's the sum over all the possible states, let's call them X. It's the probability that the random variable is equal to that state, X, times by whatever G is for this thing, let's call it G of X. So Y takes the value X. What's the chance of that? The chance is this, probability of Y equals X, and then what would this function be if Y was equal to X? It would be G of X. So it's basically probability times by this G, and then it's summed over all possible states. If you write that out more carefully in terms of probability mass functions, this thing here is the probability mass function f of x, and then it's g of x. So expectation is just, if you give me the probability mass function, I tell you what g is, you take the f of x and the g of x and multiply them together and you get your expectation. Yeah, that's the basic idea. So the simplest case would be the expectation of y. So in here you just have x times f of x. Yeah? So that's expectation for discrete random variables. For continuous random variables, you have to replace the sum by an integral. So instead of the sum, you get integral of the probability density function now, g of x dx. So it's the density of being in this particular state, gives you the idea of whether your x is in this state, and then whatever the value is of the g function at that x. Yeah, and that's the definition of expectation. So if you give me, so in this case this was the PMF, the probability mass function. Here it's the PDF for continuous variable. So that's a great idea. So that's an operator we can apply. Quite often we use that in statistics. Expectation is very often used in trying to understand what's going on in models. The other concept we use is variance, and I don't mean the sample variance, I mean the theoretical one, and that is defined in terms of these expectations. So the variance of a random variable y is defined as the expectation of y minus the expectation of y, all squared. Now it turns out you can simplify this if you go through the maths, and it turns out that's the same as writing e of y squared minus expectation of y, all squared. So if you have a way of doing expectations, which is these methods here, basic variance is just a couple of expectation calculations. You have to work out the second one here, and the expectation of y squared, and you have to work out the expectation of y. And then you do this and you get yourself a variance. And this will give you the theoretical sort of uncertainty in this random variable y. So this gives you the sort of theoretical mean, this gives you the theoretical sort of spread of the variable. And these are theoretical concepts. They're based on knowing these functions f, the PMF and the PDF. So these are not sample quantities. So I'll stop there. Thank you.